Alright, so we need to find the total magnetic field at point P1. We'll start there. So the magnetic field due to wire A, due to the right-hand curl rule, goes into the page on this side and out of the page on this side. For wire B, the right-hand curl rule tells us that the magnetic field goes into the page on the left side and out of the page on the right side. So the magnetic field at P1 is going to have two contributions that are both into the page. So we're just going to add them up. We don't have to subtract or anything. And it's just a matter of determining the magnitude of each magnetic field. So for A, that's mu naught times 4.1 over 2 pi times 0.14. So that's 5.86 microtesla into the page. And the magnetic field due to wire B will be mu naught times 2.6 over 2 pi times 0.08, and that is 6.5 microtesla into the page. Okay, so the total magnetic field at point P is, if we take, well, we just have to add them together. So it's 5.86 microtesla plus 6.5 microtesla, which is 1.2 times 10 to the minus 5 Tesla into the page. Okay, you can either make them both positive or make them both negative. As long as you're consistent, that's fine. Now for part B, we need to find the distance from wire A where the total magnetic field is equal to 0. So if I consider wire A and wire B here, the answer cannot lie in here because both magnetic fields point into the page, so they can't cancel out. If you're over in this area, the magnetic field due to wire A is out of the page, and the magnetic field due to wire B is into the page, but the magnetic field from wire A is always greater. Whether you're closer to A or further from A, you're always going to be closer to wire A than you are to wire B, and the current in wire A is greater, so the magnetic field contribution due to wire A is always going to be greater on this side. So you got to be over here somewhere. Okay, so we'll say that this distance to our point is x, and then this distance will be, I guess, x minus 0.22 meters, right? Because the separation between the wires is 22 centimeters. Right? And so if we add 22 plus x minus 22, that equals x. Alright, so I'm going to set the magnitude of the magnetic field due to wire A equal to the magnitude of the magnetic field due to wire B. That means mu naught IA over 2 pi x is equal to mu naught IB over 2 pi times x minus 0.22. And the mu naught over 2 pi goes away, and I can rearrange this as IA over IB is equal to x over x minus 0.22. And IA over IB is 4.1 over 2.6. Okay, so if I cross multiply, I get 4.1x minus 0.902 is equal to 2.6x. So 1.5x is 0.902, and x is therefore 0.60 meters. So that's how far you are away from wire A, 0.60 meters. And it's greater than 0.22 meters, right? It's greater than 22 centimeters, so that makes sense.